Hello everybody. Okay, so we're doing properties of exponents and logarithms. So this is kind of familiar to the properties of exponents page that you had before midterms. Now we're going to introduce some properties of logarithms. Some apply to both. So you'll just see, I've kind of tried to cut it and paste so that this will work out the best way for my screencast, but we'll see what happens. So definition of logarithm, we've been using this one a lot the past couple of days. So it says, and you're going to obviously put this in the logarithm column, if a equals b to the x power, then log base b of a equals x. So if you want to put an example in, as an example, 8 equals 2 to the third power, then log base 2 of 8 equals 3. Okay, that's definition of a logarithm. Nothing in exponents because obviously that's a logarithm property, not an exponent property. Okay, so next should have, whoops, not that one here. We should have the product property. So the product property, we have product property for exponents and for logarithms. So for exponents, so that's the middle column here, exponents we have a to the m power times a to the n power, so same base, different exponents. When they're being multiplied, when the bases are being multiplied, we add their exponents. So for example, if we have x to the fifth power times x to the second power, we get x to the seventh power. The property for logarithms is different. If we have log base b of x times y, then that is equal to log base b of x plus log base b of y. So remember, since log and exponential equations are inverses of each other, the properties are reverse. So when I'm multiplying in exponentials, I add the bases. When I'm multiplying for logs, I'm adding each log separately. So the example here is, let's say I have log base 3 of 5x. So this again, this is really 5, right, times x. And yellow, I don't know if yellow is a great color to use. Let's put that in blue. Okay, so 5 times x. So what happens is this equals log base 3 of 5 plus log base 3 of x. And then I can solve from there and find out what x is. Okay, so there's product property. Okay, next property should have quotient property. Sorry, that one's a little bit blurry, but it's the quotient property, third property down on your page. Okay, so quotient property, also exponents and logarithms. So for exponents, the quotient property says if I have the same base and I'm dividing, you guys should know this one already, you are going to subtract your exponents. So for example, if you have x to the 10th over x squared, you subtract your exponents and you get x to the 8th. For logs, this property says if you have log base b of x divided by y, then that is equal to log base b of x minus log base b of y. And for your example here, let's say you have log base 5 of x divided by 25, then this would be equal to log base 5 of x minus log base 5 of 25. And you would be able to figure out from there with using this subtraction. Okay, so there's the quotient property for exponents in blue and for logs in green. Moving right along, next property is the power property. So we do have, there's a couple of power properties, but this power property is the one that applies to logs. So the power property, this one's just for logs, says that if I have log base b of any number really, but let's say it's x to some power, then this is equal to that power, so that n, being multiplied by the log base b of x. So I can take that exponent on the end here and move it down in front and multiply then by just what the log is. So for example, let's say you have log 5 squared. So remember, sorry, I was trying to fix that 5 without, okay, so log 5 squared. So remember, if you don't see the base to a log, what is it, everybody? Yes, it's a 10. Okay, so let's say we have log base 10 of 5 squared. This could be written as 2 times log base 10 of 5. And again, you don't need to put in the 10. That's just the reminder that it is base 10. So you can bring the exponent down in front of the log and be able to solve for it there. Okay, so that's the power property. Okay, next. Whoops. Next. Power of a power property. Sorry for that brief interruption. Okay, so back, where was I? Power of a power property. So this is just for exponents. So this one we've seen before. Power of a power property is just, whoops, just for exponents. So that is when you have base to some power with another power working on it, and this is where we multiply. So m times n. So for example, if you have 5 to the third power and then you have x outside that, this could be 5 to the 3x power. Or another example with numbers, so let's say you have x to the third and then raised to the fifth, then this would be x to the 15th power, and you multiply your exponents. We've seen that. That one's not new. So moving right along. Power of a product property. This one we have also seen before, so just go through this one again quickly so that you have it down. This is if you have two different bases that are being multiplied, or 3, or 4, or 5, it doesn't matter, with an exponent outside. The power of a product property says pretty much to distribute that power to everything inside. So this would be a to the power of m times b to the power of m. And again, this one is just for exponents, not for logarithms. So for example, let's say you had 5x to the third power. This would be 5 to the third power times x to the third power, which would give you 125x to the third power. It's another way to simplify. So power of a product property, and that one's just for exponents. Next. Power of a quotient property. This one again just for exponents, something you have already seen, but we'll go through once more just for exponents. So this one is the same as a power of a product property, but this one we're dividing. So if you have two terms being divided with an exponent outside, again that exponent goes to both the numerator and denominator. So a to the n over b to the n power. So for example, if we do this in numbers, let's say 2/3 to the 4th power, this would be equal to 2 to the 4th power over 3 to the 4th power, and then you can simplify that even further. So 2 times 2 is 4, times 2 is 8, times 2 is 16, so this would be 16. 3 to the 4th power is 81, and we could simplify to here using this power of a quotient property. Okay. 3 more. Let's see if I can get through them all in the same thing here. So, Nope, did that one already. Cancel, back. Change of base property. So this, just like definition of a logarithm, is one we've been using recently, and this one is just for logs. So this one says log base b of a. If that is true, then this is the same as saying that we would have change this into log of a divided by log of b. And remember, both of these logs would then be in base 10, so that we can use the logs on any calculator. So for example here, and again this is just for logs, this is not for exponents, if I have log base 3 of 5, then this would be equal to log base 10 of 5 divided by log base 10 of 3. That's the change of base property. Just so that I don't run out of time and have to redo this and another one, I'm going to stop it here and tell you to go to the next screencast for the last two properties, because I don't want to run out of time and have to redo everything. Alright, so catch the next one right after this.